We are finally on to book number 2, Every Challenge Question, Part 18, book number 2, Chapter 1. So we're going to set this as partial fractions then. So take the denominator and try and break it up into factors. You can use factor theorem, of course. I noticed that -1 works quite quickly because -1, -4, -1 plus 6 is 0, so that works, which means x plus 1 is a factor. You could do some polynomial division if you're an idiot, but if you're not, you can just say that this clearly needs to be x squared, this clearly needs to be 6. And then here, well, we've got to aim for a single x. We're going to get 6x from here, so we need a -5x from these two here, and this will all balance out. And this of course, factorized to x minus 2, x minus 3. And so now we can set this as those three factors. We can set a over this, b over that, c over that. And yeah, a needs times by these two, b by these two, and c by those two. So let's do that and just set them all equal to the numerator. Denominator is, of course, irrelevant after you do that. And now I think just setting x to be things works here. So setting x to be 2 gets rid of this one and this one. And so we just end up with 3b times -1, so that's -3b. And then put in x as 2 as you get -18 here. So again, we get that, we get b as 6. And then if we set x to be 3, that gets rid of this thing, and we end up just over here. And we put 3 into there, and we get this to get this. And if we finally set x to be -1, we'll get rid of all of this and all of this, and then just put it into here, and you get this, and you get this. And then you put that in, and you finally get your answer. So nothing too tricky about any of that, just combining it with a bit of factor theorem from the top. Good, now we have a proof by contradiction. So what you want to do is you want to sort of pretend that you've drawn a line from the center to here, where that makes a right angle here, instead of where it should make it one, obviously. So we're just going to assume that this isn't a right angle here, and therefore there must be somewhere on this line from this point to the line that does make a right angle, so we'll sort of awkwardly draw it here. But now this will, of course, make a contradiction, because, of course, OB is longer than OA because B is outside of the circle, so this length must be longer than this one, because this is just the radius. But if you're going outside the circle, you need to be bigger than the radius. However, this triangle is apparently right-angled, with this being the right angle. So therefore, OA is the hypotenuse of that right-angled triangle, which means OA is the longest, and therefore we have a contradiction. And yeah, so therefore the only place you could possibly put a right angle is indeed right here. I think that's the first chapter done.